Good afternoon, all of you. My name is Dr. Vijay Bagul. Today I will teach you about the topic lasers. Here, the full form of laser is light amplification by stimulated emission of radiation. The principle of laser is very much similar to laser. Is the microwave amplification by stimulated emission of radiation. The light emitted from the laser has a very high degree of coherence. Coherence means the wave has same frequency and phase. They have constant phase. Light emitted from a laser has a very high degree of coherence and is almost perfectly parallel to each other. The theory of laser was proposed by Towns and Shaw in 1958 in USA. The first laser was fabricated by Diploma in 1960. Yeah, the difference between the ordinary light and the laser light. The laser light is a monochromatic light. Monochromatic means the single color and having a single frequency or single wavelength. And ordinary light has no multiple frequencies and have different wavelengths. The laser light is highly directional. It is traveling only one direction. Laser light is a highly directional. It is traveling only one direction. And ordinary light travel in all directions. Yeah, coherent. Laser light is highly coherent. Means this will travel in a same phase or having a same frequency. And ordinary light travel in a different phase or have different frequency. These are the characteristics of the laser beams: coherence, divergence, directionality, intensity, and monochromaticity. First property is the coherence. Coherence means is the wave has single frequency or has same phase or same frequency. The ordinary light traveling different directions, but laser light travel only one direction. In coherent property, the ordinary light traveling different waves. They have no constant phase or traveling different frequencies. Therefore, in this case, laser light is highly coherent. Divergence. Laser light is highly divergent because laser light is spreading is very small, but ordinary light is spread in all directions. Therefore, divergence or in the form of spherical wavefront. Therefore, the ordinary light traveling divergence is very large, and laser light divergence is very small. Therefore, laser light is highly divergent. Directionality. Ordinary light uses this LED light spreading or traveling all directions, but laser light spread only parallel beam of light only one direction. Intensity as a conventional sources or normal sources. As the distance increases, its intensity decreases because the waves travel in the form of spherical wavefront. But laser light is concentrated at very one particular point. As the energy is concentrated continuously at one point, its intensity is increases. Therefore, laser light is highly intense. Monochromaticity. Monochromaticity means the single color and single frequency. The laser light is a single color and single frequency. Therefore, laser light is highly monochromatic. And ordinary light is a different color and different frequency. Therefore, laser light is highly monochromatic. These are the principles or fundamental principles of the laser. The first is the absorption of radiation. in absorption of radiation, here E1 is the ground state energy or lower state energy, and E2 is the excited state energy or higher energy levels. In normal condition or general condition, all the atoms situated at the ground levels. When photon energy supplied in the favorable condition to this ground state atom, this atom jump from when photon energy is supplied from outside atom, this atom is supplied to the ground state atom. The ground state atom absorbs this energy from lower energy level to the uppermost energy levels. That means ground state atom jump from lower energy level to the uppermost energy level, the E2 levels. In this case, this ground state atom absorbs this photon energy. Therefore, this process is called as the absorption of radiations. If more and more photon energy is supplied to this ground state atom, this ground state atom absorbs more energy and excites the different energy levels like E3 and E4 levels. Just emission of radiations. Atoms which are in the excited state always try to come down the ground state by emitting extra energy in the form of emission of radiations. There are two ways of emission of radiation. One is the spontaneous emission of radiation, and second is the stimulated emission of radiations. Then spontaneous emission of radiation, here E1 is the ground state energy level, E2 is the excited state energy level. Here initially the atom, here initially the atom present in the excited state energy level, the E2 level. It may spontaneously emit the energy and come down to the ground state. Here during this transition, a photon will be emitted. During this transition, photon is emitted. And this emitted photon is highly incoherent. Hence, incoherent means these are not in same phase or same frequency. They have different phase and different frequency and travel in all directions or randomly moving in all directions. There I indicate the energy is a ratio is the E2 minus E1 energy or photon energy. This process is called the spontaneous emission of radiations. Second is the stimulated emission of radiations. Here E1 is the ground state energy level or E2 is the excited state energy levels. In this case also atoms present at the excited state energy levels, the highermost energy levels, and this state is called as the metastable state energy levels. When photon energy collide to the excited state atoms or metastable state atom level, then this collision can force or stimulate the atom to drop to the lower energy levels. During this transition, new photons will be emitted in addition to the incident photons. Means we will get two photons. One is the incident photon and another is the emitted photons. These two photons having same frequency or same energy, and they are coherent. Again, this process is called the stimulated emission of radiation because it is stimulated by the incident photons. Again, these two photons collide with the excited state atoms. We get 4 photons. Again, these 4 photons collide with the excited state atoms. We get 8 photons. This multiple process is going on. Such process mostly used in metastable state or laser actions. Population inversions. Here, even with the ground state energy level, E2 is the excited state energy levels. But at normal condition or normal states, all the atoms located at the ground states. And N1 is the number of atoms present at the state E1. And E2 is the number of atoms present at the excited state energy levels. Therefore, at normal condition, N1 is greater than N2 or energy level E2 is greater than E1 because higher state energy level because the higher state energy level should be more energy than the ground state energy. Then, but in population conditions, yeah, number of atoms should be present or accumulate at the maximum energy level at the N2 levels than that of the ground state energy levels. Therefore, in population inversion, large number of atoms accumulate at the higher energy levels than the ground state energy levels. This technique is called as the population inversion. Means number of atoms present at the external state or higher energy level than that of the ground state energy level. And last is the metastable states. Here, even in the ground state energy level, E2 is the external state energy level and E3 is the also external state energy levels. Here normally all atoms present the ground state. When photon energy is supplied to the ground state atom, then this atom absorbs this energy, jump from lower energy level to the highermost energy levels. But this atom do not stay for a longer period of time because the lifetime is very less, 10 minus 8 seconds. Then this atom immediately come down to the ground state. So in this way, population inversion would not be achieved. So to achieve the population inversion, we must have an energy state such as have longer lifetimes. Then in this it is the metastable state. In this case, large number of atoms are spontaneously emitted at the E2 levels. Large number of atoms accumulate at the E2 levels, and E2 levels hold the atom for a longer period of time. 10 to minus 8 to 10 to minus 6 to 10 to minus 3 seconds. Therefore, population inversion is achieved between E2 and E1 level. Condition of population inversion is number of atoms present in the higher external state than that of the ground state. Then the population inversion is achieved between E2 and E1 levels, and we get a finally a lesser level.